Okay, this is the third of three parts that we're covering for this first half of this module, and this is program creation and management. So this unit is not about how to write programs, rather it is about where they come from, how they are created. And it delves into how they are managed by host computers and CNC controllers. Later in another chapter, chapter 26, which is not going to be something that we'll focus on in this class, but we will open Mastercam X and write a program. So you might want to do a little research on that. If you find that that's something of interest to you, that you'd like to get a chance to get some hands-on experience. Programs are based on drawing. Today, nearly all programs originate as digital part drawings or solid models. Not just any screen depiction of an object will work for a CNC application. They must be in a special form. So for CNC part model geometry, images on a computer screen can be two different forms. Either can be raster or vector. To be an entity and useful for CNC work, lines, arcs, surfaces, and solids must be created in vector form. A vector is as real as it can be in a digital form. For example, if it's a line, it has a location starting point and an end point and a direction start to end. A solid volume and weight. A solid has volume and weight because they are entities that can be manipulated, moved, turned, or copied, shrunk, or expanded. So think about that a little bit more. A raster entity is nothing more than different colored pixels in a bitmap. It only looks like the object. It has no definition other than its pixels, location, and colors. So some raster images can be converted to vectors using special filters, but as they are useless for CNC work, so that's something you can be thinking about that. So all CAM and solid model programs create program-ready entities. So let's have an example for a vector, and the next three charts will show an example of the creation of a rectangle of vector lines that copied at 1 inch deep in the Z direction. Then the two vectors will be joined, rectangles will be joined with more vector lines to form a cube of lines. The computer recognized it as a unique figure, and as such, it can be manipulated. So we're seeing that progression here. This rectangle was created with vector lines. We then translate and connect the cube, and so we have two rectangles, put them together, have lines, and then one can, quote, grab it with the mouse and move it because it is connected vector. So we don't have that with these PowerPoint slides, but you can actually see in various orientations. And hopefully you're getting the point of that as we're going through this. So there's three kinds of geometry: wireframes, surface, and solid models. So let's take those one at a time. For a wireframe is useful for part shapes without complex surface contours, although low-level geometry, even today, they can be a fast way to get a job going on a lathe or mill. The cube in the last slide was a wireframe diagram. The software does not recognize it as a solid, nor does it have any volume, only lines. So that's what we're seeing for a wireframe. So how do we use a wireframe model? Some automatic programming functions are not possible with wireframes. Lacking volume, certain automatic CAM functions cannot be used. For example, the computer cannot know which side of the line is material, which is open space. To begin a cut, the programmer must indicate which is metal, which is not metal. Using a solid model, the CAM program knows the difference automatically, so that would be an advantage there. So for shape surfaces are halfway from wireframes to solids. Think of them as shape skins. They are defined by directing and defining lines, curved or straight. More than one can be joined together, but they do not represent a solid. They do not have any volume. They work well for complex shapes that can be defined. For example, one of the students that was related to this material we're talking about here made a skateboard mold with plenty of complex shape using surfaces as its own part geometry. So what about surface of a rotation example? So this is an example using Mastercam that I mentioned before, drawing an axis of rotation and the shape definition. Now that you have that shape definition, the software, you can direct the software to rotate the curve around the axis 360 degrees to form a surface. It then could be used as part of a model for a CNC lathe program. Once again, we need to keep in mind that this is only a skin. There is no volume. So next, solid models. Solid are studied in chapter 25 and 26 of the overall textbook. We'll not get into that here, but for now, think of them as a clay lump with volume. One could add to or subtract from the lump. You begin by defining a base and shape it as one with wood with clay. You can even make two pieces and then join them. Solid modeling is a joy to do. And so it can be, maybe for some of you, that would be a creative outlet for you. And you can see the advantage of some of the things we're getting into. You'll create this solid in two different ways in exercises if you want to be doing that. And some of you are already familiar with SolidWorks and then Mastercam. For both exercises, you will have your own personal copy of the programs to use at home. So once again, that's not going to be part of this course, but those are some resources that you can pursue if you're interested in. When the solid is done, you can go to the website for coaching and write a program based upon it. Once again, we're not going to be doing that, but those are some interesting resources that are available. Solid bring some awesome advantages to manufacturing by telling SolidWorks what the material is used. It can weigh it. It can even test it with pressure or force and stress. It can even cycle load the cyber material to see how it functions under loads and show where it fails and must be improved. If it's a moving assembly, one can even do time study to find interference points. When programming in Mastercam, solids make it more automatic and easy. Using functions like feature-based machining, dynamic pocket milling, or rest mill, which are once again studied in a later chapter, the program automatically removes material, but only if the part geometry is a solid. So we'll just conclude here for this first part of the module 2 with this third segment. This is a great time to be entering a career in CNC. There are so many areas in which our technology is advancing, cutters and how they use them, CAM programming to become even more intelligent, and CNC controllers and the machines are all evolving at a fantastic pace. And we're all here to witness that. Okay, I'll go ahead and stop there. And that's the last part for this first module, and the first of 2 modules in our second week that we're covering.